Hello, my name is Raghav Gupta and today I'll tell you something about fluid fill algorithm. So, before getting to know that what's this algorithm, how is it used and how is it implemented, let's take a look at this really interesting game. So, we all know this game, right? It's Minesweeper. It used to come with Microsoft Windows 7, XP, and it like triggers the nostalgia, right, of the childhood. We used to play it for hours in our computer labs. So there's this particular thing that this grid, the moment we click on any of the square, so you can see that a particular pattern forms. But you'd be wondering that why do we in algorithm class, why are we discussing about this game, right? Okay, down the memory lane, let's look at one of the most nostalgic software which I have ever used. So you can see here, it's the Microsoft Paint. Remember when we used to be 10, 11 years old and we used to be like paint on it, we used to have some fun. So there used to be this really cool feature in which if we draw a shape like this, so we can like segment it into any parts and we had this bucket fill color. So the moment we used to click on any color and click on the area, it would automatically paint all the surrounding area on it. So it left me wondering that how is are all these things happening? So the answer is fill algorithm. And let's see that how is it like the step-by-step implementation, that how does this algorithm actually works. So as we have seen that where do we use this algorithm in real life. So let's see that the step-by-step implementation of this algorithm with this simple example. So let's say we have a figure like this. So now in computer science, we all know that every pixel is presented on a display as an 8-bit or a 10-bit vector, which contains information such as RGB values, depth field, contrast, etc. So for simplicity, let's take a lighted pixel value as 1 and a non-empty pixel value as 0. So now this figure would look something like this. So now let's say that this picture is in MS Paint and we drop our fill bucket tool here. Let's say this position is x comma y, which is this. So now what the flood fill algorithm does is that it takes this filter. It's not technically a filter, it's just a shape. So it takes this shape and applies it on the initial x comma y, which is this. Now what it does is that since the shape is applied on this, the covered areas is this, 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 this and this. It checks that whether the area is already filled or not by this value. It's not, it's already 0, okay, so it's 0. So it checks if it's not filled, then it fills it like this. Now it moves this pointer to the adjacent side. So it will move it here. Here it will check that okay, this value is not printed, so let's color it. This is already colored, no need. This is not colored, color it. And it's a 1, so we will not color it. Similarly for here, when it comes here, it will color this and this. Now as it moves downward, it will say that okay, it's not, it will apply this, so it's colored, but it's not colored. Now it will go down and it will check whether it's colored or not. It will go here. It will check this, it's colored. It will go here. It will see that it's not, it's colored, no required, no required. It will color this. And hence the area surrounded is colored accurately. Now a question arises that why is this figure is like this? Like why is this figure like this? And not and why does it not has these diagonal components to increase its surface area? Let's take this example. So as we can see that if this is our screen, if this is our main screen, then we can see that these both areas are empty. Now here we can also say that this is also an empty area surrounding the figure. Now, if we take such a diagonal figure and apply it on this square, then it will obviously cover all these areas, but it will also cover this square block in here. And since this square block is not bounded by this line, we can say that this is the square block which we are talking about. It's not bounded by this figure, but by the virtue of the construction of this filler, this will also get colored and will give us inaccurate results. Hence, we don't use a shape like this. Instead, we use a shape like this. Now, we have seen that how this algorithm is implemented and what are its uses in real life. Now let's see the pseudocode as you can see behind me. This is the pseudocode using the recursion method for our Fluxfill algorithm. So here you can see these x comma y are actually in fact the point as explained on the board, the point where the user clicks the fill button. So these would always reside inside the area of our of an object. Now you can see that this the recursion call in these four. So it has x plus 1, x minus 1, y plus 1 and y minus 1. Why so? As discussed previously, there was this filler, right? So it had this plus shape, as you can see right here. It has this plus shape. So so if we take this x comma y, then we can take this y plus 1, y minus 1, x plus 1 and x minus 1. Okay, so as we recursively call all these functions, we will search this that whether x or y, if they reside outside the screen, then we will not do anything, or as here we can say we will return them. And if it's not same as previous one, then we will also return, which means that if they reside on these boundaries, on the boundaries which I showed you previously, so if they reside on the boundaries, then we will also not do anything as they are the boundaries of our image as known as one in our previous blackboard scenario. Now let's look at how this is implemented in C++ and let's see a demo of this algorithm. Okay, so here we can see the implementation of fluid fill algorithm in C++ 17. So let's start with the code discussion. So here we can see we have a matrix like this, and each matrix has each position in matrix has a designated number. So here we can see that there are some zeros, there are some ones, there are some twos. Now we can see that these two are in a particular area. So like these, and these are associated. So let's say this is an image made in Paint, which is shown in like this. Now we take this position 4 comma 4. So it would be 4 comma 4. This it would be this position, right? So 0 1 2 0 1 2 3. Sorry, 4 comma 4 would be this. Yeah, this would be our 4 comma 4 position, right? Now what we do is that the moment user clicks on this position, it should be replaced by a new value. Let's say there's a new color in market which has a value of 9. Now all the 2's in this area should be converted to 9. Let's take a 2 here also. So let's verify that whether our algorithm is correct or not. So the moment I run this function, so we can see that. Okay, so here we can compare our results. So this 2 is this 2, just a sec, sorry. So this 2 is still unchanged in here, as we can see here. But all the other 2's in the bounded area, this bounded area, have been changed by 9. Let's try this another way by taking the outer area 1. So the position of this 1 would be, let's take this one. So it would be 0 comma 1. So we'll take our x to be 0 and y to be 1. Sorry, yeah. And now let's take a new color. So let's say 6. Now all the ones which are in this area, not encapsulating any other object, should get converted to 6, which means that except these zeros and twos, all the ones surrounding should get 1, should be get converted to 6. Just for the verification, let's make this change and let's add a 1 in between. So we have this 1 in between here for the verification. And the moment we run the algorithm, you see what happens. So yeah, so we can see that except the uh, except the one in the middle, all the surrounding ones have changed to 6 wherever they were encapsulated by a boundary. Now let's see that how the code runs. So the moment we run the code, everything gets initialized, and this function is called known as flood fill. In this flood fill, it calls this flood fill util function, which is a recursive function. So each and every time it stores it checks for the exit condition, which are base cases as explained earlier in the pseudocode. Then it will replace the color at every x and y. And as we seen for the filler, it goes to x plus 1, x minus 1, y plus 1, y minus 1, x, y, y, y. So that's how the whole matrix gets modified, or as we can say, an image or a vector object gets modified by this algorithm. Thank you for watching my video. I would like to thank Dr. Tanveer Ahmed to give me this a brilliant opportunity to showcase my skills and make people enlightened about Flood's fill algorithm. Thank you.